Well, the lighting got better on the side of the board because it's dark outside now. And so let's get back started here again with the 2022 12A Problem 11, the first one in the set of this rapid fire. What is the product of all real numbers x? So real numbers, keep that in mind, such that the distance on the number line, we also want product, distance on the number line between these. So anyway, distance on the number line is just absolute value of their difference. So you're looking at the absolute value of log base 6 of x minus log base 6 of 9. That needs to be equals twice the distance on the number line between log base 6 of 10 and log base 6 of 6. Again, convert things as you read them in the context of the problem. So if we write that way, in fact, on my paper, I wouldn't even write the difference for that one. I would just immediately apply the log rule of log base 6 of 10 minus log base 6 of 6 becomes log base 6 of 10 over 6, which is 5/3. Okay? 1 equaling log base 6 of 6. So over here, the thing is, we don't know if this is larger than that or not. So if it's larger, basically, how would it be larger? Let's first write what this one is. You'll kind of see it. You'll get the absolute value of log base 6 of x over 9 equals 2 times. This is, here's the thing. If you don't know, all logs pass through the point 1, 0, as long as they're not shifted, translated. So you're going to be coming through like this. This is what the graph looks like. It's good to have all the graphs kind of, the basic parent graph memorized just for this kind of purpose. So you can see that if you are to the right of 1 as far as your input value goes, which 10 over 6 is greater than 1, we know this is positive and it doesn't need the absolute value. So we can just call this 2 log of 5/3. Okay, now what about this one? Well, let's just kind of give it parameters. If x is greater than 9, then this would be a positive value because that input value, the argument of the log, if you will, would then be a positive number. So you could say that it's going to be log base 6 of x over 9 would equal log of 25 over 9. Now, what did I just do, by the way? What I just did was took this 2 and put it up there. I like to visually remember my log rules. So for me, I will look at log base b of a to the x. I grab this exponent and I drop it in front like that. That's why I wrote my paper, just like that. Because it reminds me of what to do with it. But it can also work in reverse. If it's here, it can also go back over there. It can move back and forth. Okay? There are certain situations you got to be careful with that. For example, if you were looking for a domain, right, and you had log base b of x squared, this x can actually be negative. But if I write it as 2 log base b of x, now it can't. And so they're not quite exactly, but it's if x is positive that they're exactly equal. Okay? And the domain of this one would be restricted to the standard domain, whereas this one's domain could actually include negatives as well. So let's go back over to here, though. We're not doing that in this problem. Now that we have the bases the same, log base 6 on both sides, it just means the inside parts are equal, and you're going to get x equals 25. I'm going to go ahead and erase this graph now so I can do the other one. Now, if x is less than 9, that means that I would have reversed the order of this, right? Again, that same absolute value trick. The absolute value of a minus b is equal to a minus b if a is greater than b or equal to it, and you just switch the order if a is less than b. So if x is going to be, this is going to be less than that, we switch the order. And that's what we'll do here. You're basically just going to flip this fraction upside down, right? So you're going to get 9 over x equals 25 over 9. I'm going to go ahead and just, swap these corners and multiply that one up to there. So I'm going to get x equals 81 over 25. It's equivalent to cross multiplying, really. But what I'm kind of seeing in my head, though, is that I'm looking at it like this. 9 over 25 equals x over 9. Notice that's the equivalent of doing a reciprocal because these are both 9s in this case. But you can swap corners on proportions whenever you want, and then I just multiply both sides by 9. It's probably just as fast to cross multiply. It's just, I like doing things in weird and interesting ways. So we're going to take this 81 over 25. We want the product. Those are the only two values. So you'll multiply 81 over 25 times the other x value. You'll cancel the 25s. You'll get 81. Let's do problem 12. Okay, so now we're doing the 2022 AMC 12A problem 12. Let M be the midpoint of segment AB in regular tetrahedron ABCD. Let's just kind of stop there. I'm going to draw here something like this, and I'm going to kind of just do it like a straight down view, I think. I don't know why. This is raised off the board, if you will. We'll call this A, B, C, and D will be up there. M is the midpoint of AB, as it says. Okay, what is the cosine of angle CMD? Well, first off, a regular tetrahedron means they're all equilateral triangles, right? So if I connect M to D, you're looking at the height of an equilateral triangle. And we don't know any dimensions, right? So if I don't know dimensions for equilaterals, I like 2 for the side length because it cuts in half nicely and it doesn't have to deal with too many fractions. So I'm going to call that root 3. So MD is going to be root 3. And you say, yeah, but what if it was a different length? Doesn't matter. It'll work out fine. The angle is going to be the same no matter how big it scales. Okay? So it's going to be a similar solid, if you will. All right, then what about CD's length? CD's length would be, what I'm saying is that AD is 2 and DB is 2. This is that triangle with A here, M here, B, well, kind of, D is here actually, and then A would be here and B would be here, something like that. Okay, so, but you see that the side lengths of our triangles and therefore are the edges of our tetrahedron are all going to be 2. And as a result, CD will be 2. Now, what is CM? It's just the altitude of the triangle on the base, ABC. Just like this one, it's radical 3. So CM is radical 3. What do we have? We have a triangle, and if I think about it, I got a triangle that's root 3 by root 3 by 2, and I would like the angle in between the root 3's. So what am I going to do? I'm just going to redraw it over here, separate triangle, isosceles, root 3, and 2. We're looking for the cosine of this angle. You could do law of cosines if you wanted to. You could also do what? I think what I would do is drop the altitude, and I put theta here and here instead, and now you're looking for the cosine of 2 theta. And you should have memorized these, but if you didn't, you can also derive them from the sum formula theta plus theta. And so, for instance, this one would be my mnemonic device is crazy cousins, silly sisters, which means it's cos. Had this been A and B, it would be cos A, cos B. That's the crazy cousins. It's the opposite sign in the middle, sine A, sine B. But when these are both theta, we can drop theta into both A and B. We're going to get cosine squared of theta minus sine squared of theta. Notice that cos of 2 theta is equivalent to the cosine of the angle we had here originally. So from this point, what is the cosine of theta? It's adjacent. Again, this will be 1, and this will be radical 2. Okay, why? This is a 90-degree angle, isosceles triangle. When you drop the altitude and the angle bisector, they're the same line, and it's the median. So this is 1 as well. That's for any isosceles triangle, including equilateral triangles. If you do Pythagorean, you'll get 1 squared plus root 2 squared is root 3 squared. It checks out. Cosine then is going to be root 2 over 3, root 3. And we're going to be squaring that, so we write 2/3 minus opposite over hypotenuse, 1 over root 3 squared is 1/3. 2/3 minus 1/3, get 1/3, and that is our answer. Let's go ahead and do problem 13. let's get on with problem number 13 from the 2022 AMC 12A. I didn't really find this one that bad. I think I spent maybe 2 minutes on it. We'll get started about why that was, maybe 2.5. Maybe I thought about a couple things first. Let R be the region in the complex plane consisting of all complex numbers Z that can be written as the sum of complex numbers Z1 and Z2. So Z is going to equal Z sub 1 plus Z sub 2, where Z sub 1 lies on the segment with endpoints 3 and 4i. So let's go, where would those be? 3 is going to be here. You know, it's A plus BI. A is the real part on the real axis, imaginary axis here. You've got 3. 1, 2, 3, 4. This would be 4i. So we got a segment just like that. Okay, that's going to be Z1 lies on there somewhere, and Z2 has magnitude at most 1. So magnitude at most 1 would mean that if I let Z2 equal C plus DI, the magnitude is C squared plus D squared square rooted. It's kind of like distance from the origin. In fact, that's what it's describing. It's describing a circle centered at the origin where Z2 has magnitude at most 1, meaning it could be any point in that circle. All of those points are 1 unit or less away from the origin. So what integer, I had to put a caret there because I messed up, I didn't want to erase, what integer is closest to the area of R? Again, one more time, R is the region consisting of all complex numbers Z that can be written as the sum of these two. So I took a little bit, I thought about how would I want to represent this if I made that one this and C plus DI. I was like Z will equal A plus C plus B plus DI. And I thought, that doesn't look that great. So I decided what is really going on here? Magnitude kind of makes you think of vector. And so if you think of it as a vector, Z2 is essentially a directional vector coming off of this segment going 1 unit in any direction from any point on there. And that basically breaks the problem once you realize that. So if I come out 1 unit here and out 1 unit there, and I go a rectangle up to here, and I go like this, all of those points would be in there because they're all 1 unit away from that segment directly. Furthermore, from this point at the middle of the top end, you're going to get a semicircle and another one here. Kind of looks like a basketball, court, a pill, yeah, something, a track, there you go. Anyhow, what's the length of this line? It's just the length of that line. It's going to be square root, it's 3 squared plus 4 squared. You should know it's 3, 4, 5 triangle because you have the right triangle here. So that length is 5, whereas this right here is 1 plus 1 is 2. So you're going to have 5 times 2 is 10, plus the circle of pi, pi being approximately 3.14. Add those to get 13.14. Select 13 because it's the closest integer. It makes sense now why they asked for the closest, because obviously we're going to get an irrational value for that. Let's go ahead and do problem 14. All right, for me at least, I found the algebra in this problem quite satisfying. I did go kind of off on a couple different paths first, spent about 2 minutes wasting time trying to just call this a variable and that a variable. I did also split this into log 5 times 4, made that log 5 plus log 4, and then I thought, okay, I'd have something like a cubed plus a plus, I made it log 2 log 2, so log 4 into 2 log 2. So I had this, and then I tried messing around with that. Ultimately, those didn't really feel like I was getting anywhere, so back to the drawing board, and I ended up noticing some other things. There was something about the 5 and the 20, and it was, I've seen this in a pre-calc textbook before where you're working with base 10 specifically, And one of the tricks on there was to consider them like log of 10 over 2 instead. And so if I say log 5 equals that, then that's going to equal log 10 minus log 2. Log 10, of course, being 1. It's a question. 10 to what power equals 10 minus log 2. I don't want to write log 2 anymore. Guess what? X is log 2. We've got 1 minus x is log 5. Let's plug this in and see what happens. 1 minus x cubed. It's a really important game, by the way. See what happens. Sometimes we try to see what happens in our brain and then don't go down a path. And then later when the test is over, we're like, oh, if I would have just done that one thing, it was obvious after that. That's the cry of regret. So make sure that if you have the time, you at least go a little ways down each problem just to see, maybe it unravels. This is going to be what? Well, if I did this with 10 over 2, what would I do with that one? We could say log 20 is equal to log of 100 over 5. And that's going to, in turn, just like this, it'll be log 100 minus log 5. Log 100 is 2 because it's the second power of 10. But wait, log 5, we've got that right here. It's this. So now it's 2 minus 1. Well, that's not, where'd the 1 go? Like my brain said it, but my hand was like, nope, not going to write that. 2 minus 1 minus x, and then that's cubed. So now we can put that here. In fact, let's go ahead and simplify. 2 minus 1 is just 1, and negative negative is positive x. So you're going to have plus 1 plus x cubed. And then over here, log 8. Also, the log of 0.25, right when they write something like that, typically what you want to do as a general attack plan is if they give you things, change their appearance. Make them look different in some way. Why is it a decimal? 2 reasons. It's either a hint about some advantage you gain from decimals, or they're trying to disguise something. So what if I wrote it as a fraction? This one's going to be log of 2 to the third. We'll grab that 3, pull it in front. 3 log 2. The other one is log of 1/4, which is equal to log of 2 to the negative 2, which is negative 2 log 2. So log 2, oh, that's x actually. X is log 2. So since x is log 2, what do we have? We've got 3x and negative 2x. Okay, well, that looks nice. We're trying to find the value of this. You've now got essentially a cubed plus b cubed, and a cubed plus b cubed is going to be a plus b times a squared minus ab plus b squared. You need to memorize that if you haven't. Same for the minus one. Put it in the small notebook if you don't have it there. So now what? A plus b is this. A is the entire expression. It's 1 minus x. B is that expression. If I add those, I'm going to get 2 because the negative x and x cancel. So I'll have 2 times a squared is 1 minus x squared, which is 1 minus 2x plus x squared, plus, no, minus actually. So we're going to have minus. Be careful, that minus is this minus. Don't lose it. You'll make mistakes. I want the product of this parenthesis with that parenthesis. So 1 minus x, that's just difference of squares. It's going to be 1 minus x squared. Next, you're going to have plus b squared. That's this one squared. We'll expand it. 1 plus 2x plus x squared, parenthesis, and then minus 6x. Okay, so let's clean that up and see what happens. I'm going to keep the 2 over here. I'm going to go to this side of the board so I'm not bending over so far. And 1 minus 1, those are going to cancel. I've got another 1 over there, so we'll put 1. And then you're going to have negative 2x and positive 2x. Those will cancel. You're going to have x squared minus a negative x squared. That's plus x squared for 2x squared. And then another x squared is 3x squared. I'm worried about that 1. I'm not sure it's supposed to be there. Maybe it's fine though. So 2 times 1 minus 3x squared minus 6x squared because there's two x's there. Okay, so we got that, and now we see it. It's done. You got 2, you got negative 6, and ooh, hold on. It should have been plus 3x squared. Yeah, x squared plus x squared plus x squared. You can tell I'm tired. All right, 2 times 1, 2 plus 6x squared minus 6x squared. Cancel, cancel, cancel. Get 2. Answer choice C. A really good question. There is the potential for skipping this. If you did skip it, I wouldn't feel bad. It took me, like I said, a couple minutes before I decided to go with that plan, and then it was all clear waters from there. Let's go ahead and get to problem 15. Now we are doing the AMC 10A from 2022, problem 16, and the 12A problem 15. This problem's got a couple different ways to do it. It's got more than that probably. There is a function way that you can utilize. It's not what I did when I was doing it on my own solution of the test. I'm going to show you my solution and then talk about another way that you could do it, which is probably faster. First, it is Vietta's, is the way that I did it. And so let's get started here. The roots of the polynomial, when they talk about roots, what are roots? Roots, solutions, x-intercepts, zeros. All essentially mean the same thing. By zeros, it's going to be this expression equal to 0, and then it's going to be an x-intercept because essentially you have an equation, y equals like that, and you're making y 0, which is why they're called zeros. And so here we go. We got roots of this equation. They are the height, length, and width of a rectangular box, which is a right rectangular prism. Something else kind of neat. I don't know what class it was that I was teaching, but there was a problem that came up, and we had actually designed in the class a problem that did the same mechanism. Basically used a cubic polynomial to create the roots of it were the dimensions of this, and I forget what I came up with. I think it's recorded somewhere. I gotta find it. But it's kind of neat to see the same exact idea appear on the test. I didn't think it had appeared up to this point, but maybe they're listening to my classes. I don't know. So here we go. A new rectangular box is formed by lengthening each edge of the original box by 2 units. What is the volume of the new box? So first, this is like A, B, C, and D. So I'm going to use the letters E, F, and G to avoid confusion. We know that the product of E, F, and G, these are the roots. Okay, if you don't know what I'm doing, those are the roots. So the product of those roots is going to be the negative constant over the leading coefficient. That product of roots alternates signs. So when it's a quadratic, for instance, ax squared plus bx plus c, it is positive c over a. And the sum of the roots is negative b over a. Okay? But as we move to cubics, it's going to still stay negative second coefficient over leading coefficient for the sum. So for instance, we know that e plus f plus g is equal to 39 over 10 because that's the negative second over first, which is how you want to memorize it. Don't memorize the letters because if they switch the letters on, you're going to get confused. All right, the next one is the pairwise products. Pairwise products is what it sounds like. We're taking these and we're making them into pairs. That would be E with F, E with G, and F with G. And so we're going to get EF plus FG plus EG, for example. All right, that's a pun. Anyhow, this is going to equal 29 over 10. And it's the positive 29 over 10. So the way it's going to work is going to alternate signs. The sum is always negative second coefficient over leading coefficient. But the next one on the list when you're doing this as you go up in polynomials is going to be now a positive third coefficient over leading coefficient. And then the all three of them multiplied together, E times F times G. Notice what we're doing. We're pairing them or putting them in groups of 1, groups of 2, and now groups of 3. And there's only one group of 3 when there's 3 things. And so E times F times G is going to equal 6 over 10. Okay, so these are our pieces. Now what? Well, we want the volume of a new box. If the roots are all going to be lengthened by 2, we're going to multiply e plus 2 times f plus 2 times g plus 2. And now you're going to distribute this. I'm just going to do it in a normal way. E plus 2 times f plus 2 will give me ef plus 2e plus 2f plus 4. I'm going to put g plus 2 in front. I'm going to distribute the g. You get e times f times g plus 2eg plus 2fg plus 4g. And then now you're going to distribute the 2. You're going to get 2ef. I'm going to write it right here. 2 times 2e is plus 4e. 2 times 2f is plus 4f. And finally, the 2 to the 4 makes 8. So now what do we have? This is the new volume. It's the new volume right there because the volume is length times width times height. So now what do we do? EFG is 6 over 10. Then this 2 EG, FG, and EF is 2 times the pairwise product. So you're going to get 58 over 10. Then you're going to have 4G, 4E, and 4F. That's 4 times G plus E plus F. 4 times 39 is 78 times 2 is 156 over 10. Next, we're going to add 8, but we're going to write it as 80 over 10. So now we're going to add this all up. There's 214 plus 6 is 220 plus 80 is 300. 300 over 10. Answer 30. Now, there is another way to do this. I just didn't feel comfortable with it, though I kind of thought maybe, but I didn't feel like I wasn't 100% sure that it was going to work. The idea would be that you make this into function notation. 10x cubed minus 39x squared plus 29x minus 6. And then what you would do is you would say, let's get rid of this stuff so I have some space right there. What you would do is you would say, well, since these are the roots of this, right, we could factor out a 10 from that if we wanted to and say that it's 10 times x minus e, x minus f, x minus g. And so if you think about it, if we want to add 2 to all of these roots, it now becomes x minus e plus 2, kind of like this, right? And so think about it though. What are the roots? They're x-intercepts. So if you were to graph this cubic function, and it's going to look, something like this, right? You'd have root e, root f, and root g. Well, if I just added 2 to all of those, it would be like shifting this graph 2 to the right. And since you're shifting it 2 to the right, you could then make it f of x minus 2. That will shift the graph 2 to the right. If you don't know how graph shifting and translations work, I'm not going to break it all down in this video. I could spend a half hour just explaining that topic. So if you plug this x minus 2 in, one way you could do that, by the way, is just dividing by 10. Let's get some space here and show what that would look like. If you divide by 10, you would get x cubed minus 39 over 10x squared plus 29. I don't know, maybe it's better to leave it as is. When you think about it, let's just do it as is. So you're going to have 10 times x minus 2 cubed minus 39 x minus 2 squared, and then plus 29 times x minus 2, and then minus 6. Now don't forget what we're looking for. We're looking for the product of these roots. Okay, so the product of these roots is going to be the negative constant over leading coefficient. So what's my leading coefficient going to be? 10 still. It's on the outside. So you're going to have 10, but there's also going to be, that's going to be 10x cubed. I'm not going to calculate all of this. I'm just going to find the constant on the end times 10. 10 times negative 8, because if you think about it, it's x minus 2, x minus 2, x minus 2, and you get the constant from this term by selecting the constant in each of these. Again, that idea of selecting something else they cover in the art of problem solving, especially when you're doing, I think, combinations. So binomial expansion. So negative 2 times negative 2 times negative 2 is negative 8 times 10 is negative 80. So I'm going to have other stuff, but then I'm going to have minus 80. Okay, then here I'm going to have negative 2 squared because it's x minus 2 times x minus 2. You'll have positive 4 times negative 39. Again, that's negative 156. We don't care about everything else. The linear, the quadratic term, no matter, doesn't affect us. Okay? Then 29 times negative 2 is negative 58, and negative 6. These numbers should look familiar. They are the same numbers that we had in the numerator over here, and if you add them up, you will get negative 300. And then don't forget, it's the negative constant. Since the constant is negative, it's negative 300 over 10. You still get 30. Kind of a cool way to do it though, and it does work. And now that I think about it, it does make sense because all we want is the product of the roots. We don't care how high and low it goes off the x-axis and how that might be affected. It won't affect the new volume. That's it for this problem. Last one for the set of 12A, and we'll get on to the next problem.